Optimization. What is being optimized? Well, as soon as you see minimum or maximum or whatever, that's an optimization type problem. And in these problems, you're doing the first or second derivative tests, okay? And using the first and second derivative tests help you find maxes and minimums, okay? So anyways, let's see what this thing is saying. If y equals this, okay, and you know that x is greater than 0, what is the minimum product? The minimum product, okay, so that's what we're looking for, the small product. Okay, so this is how I would write it, the smallest product. Now, here we have x squared and y multiplying to each other. That's the product, okay? So I'm going to say p of x. I'm making this up, okay? I'm saying p is our function. Why'd you pick p? Because it's a product that we're looking for. Okay, yeah, you could have used f. It doesn't matter. But p of x is x squared y. Now, the thing with optimization is whatever function you're optimizing, all right, that function needs to be written in terms of one variable. Right now, p is written as two variables. So actually, with the way I wrote this is written incorrectly. I should be writing p of x and y, meaning you have to plug in x and y, would equal x squared times y. Now that kind of derivative can be done, but if you have extra information that would make it so you can write this function as, as a function of one variable, then do it. Now you can choose either variable. You can choose x or you can choose y. It looks like p of x would be easier to write because we already have y alone and we could sub this in for y so that there are no y's. So that's what I'm going to do. I'm going to take my function right here and let's see, x squared is fine, but for the y I'm going to write 3x minus 7 and booyah. And so here's my function. It is the product function, and I want to find the minimum. What is the smallest product that I can find? And yes, Enrique, I am recording this. I got a lot of videos to upload now. So now you could take the derivative as it stands, but you're gonna have to use the product. What's that called? The product formula, the product property, the product rule. Okay, that's what it's called. Okay, but I don't want to use that because I mean, if I don't have to, I don't want to. I'm going to distribute this and make this more simple. So I have p of x equals 3x to the third minus 7x squared. Now it looks like to me, oh yeah, so this is a polynomial of the third degree. So and we also know that x is greater than 0. All right, so how are we gonna do this? Well, we're only gonna need the first derivative test on this. So let's go ahead and find the derivative. So I have p prime of x equals, see, 3 times 3 would be 9, and then I take 1 away from the power, so it's going to be squared, minus 14x raised to the first power, because I take 1 away from the x, and there you have it. Now, I'm gonna go ahead and draw a sine line graph. Now, I just noticed that all of my answers are decimals, and there's also a C right here, so this must be a calculator type problem. So as soon as I see that, I'm like, how can we use a calculator to find this answer? In order to find my critical values, I got to set 9x squared minus 14x equal to 0. This is the first derivative test. And to find that, I'm going to simplify this by dividing out or factoring out an x. So I get 9x minus 14. I set each of these factors, x and 9x minus 14 equal to 0. So I get x equals 0 and x equals 14 over 9. Okay, so I set those factors equal to 0, and that's what I get. So on my sine line graph, I have 0 as one of my critical values. Another critical value is 14 over 9, which is 1 and 5/9. Okay, I like a mixed number when I start getting onto graphs. A mixed number instead of an improper fraction. And now what I would need to know is I need to know the signs, okay? Are we plus or minus in this interval? Are we plus or minus in this interval? Or are we plus or minus in this interval? And what those signs tell you, they tell you if you're increasing or decreasing. Okay, if you know if a function, like in this case p, if you know if it's increasing or decreasing, then you can find the minimum number there. Okay, now minimum would be decreasing and then increasing. So the function would be going down then up, and then you would have your minimum right there. Okay, that would be your min. Okay, and this line right here would be your p of x. Okay, so where is that happening? Where is this minimum happening? It says, what is the minimum product? Okay, so the minimum product, it actually is the p. It's not just where is it happening, but we know it's going to be 0 or it's going to be 1.59. So how can we find these signs right here? How do we know if we're increasing or decreasing? Well, you would have to test numbers. Okay, so I would test -1 because that sounds easy. I would test 1 right here because that sounds easy. And then I would test 2 right there because that sounds easy. When you test these, you got to plug these into p prime because p prime is what tells you if the function is increasing or where the function is increasing and decreasing. So if I plug in -1 into this, let's see, it'd be 9, -1, second power minus 14, -1. What would this give me? So this would be a positive 9, and then this would be a positive 14. So this is going to be positive. Let's plug in positive 1. So 9, plug in positive 1, square that, minus 14, positive 1. Okay, we get 9 minus 14, which is negative, so decreasing. So we're increasing here, and then we're decreasing here. So it looks like there's a max here at 1. That's not what we care about. We want the minimum. So now we're decreasing. Let's see what happens after this critical value 1 and 5/9. So I'm going to plug in 2. So we get 9. We square 2 minus 14 times 2. Looks like we get 4 right here. 4 times 9 is 36. And then 14 times 2 is 28. So we're going to subtract 28. This is going to be a positive number, and so we're increasing there. It looks like right here is where we would have a minimum. Okay, that's where the minimum is, Stews. And so on the graph of P at 1 and 5/9, that's where you're going to find the minimum product. Okay, now all the numbers right here on the vertical line, those are your products. And so now we just have to find the y value there. So you could take this right here and you could plug it back into the original function to find out what that minimum value is, or we can use a graphing calculator, and it looks like I want to use a graphing calculator because who wants to raise 1 and 5/9 to the third power and set into the second power? I don't want to do that. So let's go ahead and bust out our calculator. Now, I'm going to kind of cheat here. It's actually not cheating. It's just smart calculator use. I'm going to put in 3x to the third minus 7x squared. Okay, oops, messed up on that one. Minus 7x squared. Okay, so now check out what you can do. You can go to, actually there's different ways to do this. I'm going to use a table. Okay, so I'm going to press second and I'm going to go to table. And it looks like my table is filling in by itself, which is not what I want it to do. Because see, it's only putting in integers into the x's. And I need to put in 1.5 or 1 and 5/9. So I'm going to go back to the table set. So hit second and then window. It'll take me to the table set. And I'm going to tell you the calculator to ask for the independent variables. Now when I go back to the table, oh wow, it's still here. Okay, can I put a number in here? No. Go back to table set. Yeah, I said ask. Okay, so let's go back to table. Okay, so my calculator is being done right here. Your calculator should have nothing in the x's, and it should allow you to put stuff in the x's. But my calculator is not doing that, so I'm going to try it a different way. Okay, well, I'm going to go over to my main window, and I'm going to use y sub 1 to plug this in. Dang it, that's kind of annoying. Okay, so I'm going to hit vars, go y vars, and function, and then I'm going to select y sub 1, and then I'm going to put inside of y sub 1 1 plus 5/9. That'll be 1 and 5/9. And I'm going to press enter, see if it gives me an answer. Yay, it does. Negative 5.64. Hey, there's my answer. So this is our minimum. Now, do you have to do what I did and go to the function window and plug in the function there, and then come over here and then plug in a number that way. Miss Patey, why can't I just like do 3 and then put 1 and 5/9 here? So I'm gonna put 1 plus 5 over 9, raise that to the third power, and then minus 7, and then put 1 plus 5 over 9, raise that to the second power, and press enter. Yeah, you can do it that way too. But just for future reference, oh, you guys couldn't see the function when I was putting it in there. Sorry, there it is. um, just for the future, whenever you're using a graphing calculator on a test, I like to put my function inside the function window just in case I have to use the function multiple times. That way I don't mess up using like typing out the function, because that's a very easy mistake to do. So anyways, a longer video that probably could have been shorter. I hope that helped you guys.